Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of memory management in C. Think of it as a thrilling detective story. But instead of clues, we have pointers. And instead of a criminal, we have memory leaks. Exciting, right?
Absolutely. I've always been a bit hazy on the details. So, what's the core mystery we're unraveling today?
The mystery, my friend, is how C handles memory allocation without the safety nets of languages like Rust. We'll explore the stack, the heap, malloc, realloc, and the dreaded, free, the functions that make or break a C programmer's sanity. We'll even touch upon the art of avoiding those pesky memory leaks.
Sounds intense. Let's start with the basics. What's the difference between the stack and the heap?
Think of the stack as a neatly organized stack of plates. LIFO. Last in, first out. Each function call gets its own plate, holding local variables. Yes, it's fast and efficient, but the size is fixed. The heap, on the other hand, is a giant, messy pile of plates. You can grab a plate of any size, but you need to keep track of where you put it. It's more flexible, but slower, and prone to errors if you're not careful.
I see. So, malloc, is like grabbing a plate from the heap?
Precisely. Malloc, reserves a block of memory on the heap. Realloc, lets you resize that plate if you need more or less space. And free, is putting the plate back. Crucial to avoid those memory leaks.
And what about those memory leaks? How exactly do they happen?
Memory leaks happen when you grab a plate from the heap but forget to put it back. The program loses track of the memory, and it's wasted until the program ends. It's like leaving a plate on the table after a feast. Eventually, you'll run out of clean plates.
That's a pretty vivid analogy. So, the article also mentions fragmentation. What's that?
Fragmentation is like having lots of tiny, unusable spaces between plates on the heap. You might have enough space in total, but no single space big enough for what you need. It's like trying to fit a large casserole dish into a cupboard full of small bowls.
Got it. And the article talks about a use after free UAF bug. That sounds scary.
Oh, it is. It's like trying to use a plate that's already been washed and put away. You might get lucky and it works, but it's highly unpredictable and can lead to crashes or security vulnerabilities. It's a very common problem in C.
Wow, this is way more complicated than I thought. The article even mentions that malloc, itself isn't magic. It needs to manage its own bookkeeping. How does it do that?
Exactly. Malloc, uses some of the heap to keep track of which memory is free and which is in use. It's like having a waiter who keeps track of which plates are clean and which are dirty. There are clever data structures used for this, but the basic idea is to maintain a list of free and allocated blocks.
So in essence, memory management in C is a delicate balancing act. One wrong move, and you're dealing with leaks, fragmentation, or UAFs. It sounds like Rust's stricter memory model is a welcome relief.
Absolutely. Rust's ownership system and borrow checkers are designed to prevent these kinds of errors at compile time, making it much safer. But understanding the underlying mechanics in C is crucial for anyone working with lower-level systems programming. That's why this article is so valuable. It gives you a glimpse under the hood.
I agree. This has been a fantastic overview. Thanks for breaking down this complex topic.
My pleasure. And remember, folks, always free your plates. Until next time, this is Tech Bytes and News, signing off.
Bye-bye.